recorded on this computer. And we're recording, so go ahead.
All right, well, thank you, Alice. Today I'm gonna be talking about SOMEF, which is a metadata extraction framework that basically extracts different metadata categories from software documentation. And this is the work that I started doing at the Information Science Institute, but now I'm continuing at the Polytechnic University of Madrid. So I don't think I need to highlight to any of you the importance of software metadata because many of you handle or manage software registry, right? But the important thing that I wanted to highlight here is that there is an increasing amount of software available online. And for example, last year, I checked some stats, and this may be outdated, but GitHub had more than 100 million repositories, and Bitbucket had more than 28 million repositories of software. So people are increasingly putting things in there. And here in these repositories, metadata is critical for finding, reusing, and understanding software, which actually overlaps significantly with the FAIR principles that everyone has in their mind these days. And we have also seen the efforts towards the community for getting common metadata so we can describe using a common vocabulary all these repositories. So the problem, or at least one of the main problems that I face in my collaborations with scientists, is that first scientists have to develop this software, their software, and their documentation because they usually put a lot of effort already in creating their own documentation. And then they have to go to the different registries to create an entry manually, which in some cases goes through additional effort because they have to be curated and validated. Sometimes there isn't, like in, for example, Zenodo, you just put the metadata and it's not curated. And in some other repositories, there is an expert that goes afterwards and checks that you have filled all the metadata records accordingly and correctly. So what I have been working on is on creating a framework that given a repository, now we're working mainly with GitHub, you run this framework and it runs a series of supervised classifiers, regular expressions, does a little bit of analysis of the headers that are used in your README files, and also exploits the GitHub API to extract all the metadata that we can capture or that we can think we can capture and export it using CodeMeta in JSON-LD, although we also support other structured formats such as Turtle and JSON. You can find more information about the repo on the bottom of the slide. And this is an overview of the metadata categories that we are right now recognizing. I'm not going to go into the details of all of them, but basically we started with the description, citation, installation instructions, and invocations for a given software component. And then we slowly expanded through common categories that we found that many repositories had, such as usage examples, additional documentation, what are the requirements, how to contribute, or who are the contributors, frequently asked questions, and so on and so forth. And we use, as I said, as a variety of methods based on machine learning, also based on lexicographic, basically on synsets that you have used in your headers. We also explore the files to see whether we can extract additional information such as Docker files and notebooks, which are very useful for setting up your repository and your software entry. And we also apply, well, some smart regular expressions and exploit the GitHub API. And this is an example of what we export. On the left-hand side of the slide, you can see the JSON representation, and on the right side, you can see the CodeMeta one, which, funnily enough, I checked with the CodeMeta validator, and it turns out that the CodeMeta validator sometimes fails for some of the results that we get because they don't accept multiple descriptions. So apparently description is one of the things that it has to be unique for the CodeMeta validator. But I'm just saying this in case that you want to check it out. Apart from that, I think more or less everything makes a lot of sense. And the good thing about using the JSON representation on the other structured formats besides CodeMeta one is that we also export additional metadata that right now it's not captured in CodeMeta. That's one of the interests as well that I have in maybe easing the way that CodeMeta can be expanded, because there are additional things, additional metadata fields that are very commonly present in software registries that right now are not supported by this community standard. Plus, in the JSON representation, I can also extract the confidence that I have in the extraction on every field, while in the CodeMeta representation, I just represent everything in an absolute manner. And that's it. Since I only had like a few minutes today, I just wanted to show you this tool, which automatically extracts software metadata from a given GitHub repository by focusing on the README files. And it actually brings up like a lot of potential things to do with this, because now we can let authors know which metadata is potentially missing from their README files, because sometimes they don't include it because they don't know what else is missing. And of course, it makes helps making software a little bit more findable. But there is much more to explore, because now is when we are actually starting to look at, for example, the installation instructions and the input and output files that the software produces, and how can actually we can concatenate software together. So we are scratching the surface, and I hope that maybe in 1 or 2 years or whenever I have more time to develop this, we come up with significant improvements to this tool. So if you have any suggestions and features or problems, let me know. We are continuously improving this tool, and it would be great if you want to give it a try. Thank you very much.
Okay, we have a couple of minutes for questions. So if you have questions you want to ask Daniel, please go ahead. Okay, I'm going to stop recording then. And well,
I have one.
Okay, good.
Okay. So, for example, is this, as you mentioned, it's not figured out yet how this will be distributed and packaged and used, but like would this be, for example, something that people set up as GitHub action or something, and then they run it and they let's say receive that?
Yeah,
they
that
get
would
the
be.
output and...
So I haven't set up like a proper service right now, but yes, that's one of the things. In fact, I've been talking with some of the people that are on the Fair group for Fair for Research Software, sorry, and they have tools that they are starting like to label how fair your research software is, and I think that together with this kind of thing, it would be very useful. Like, hey, well, you just first check how fair your software is, and then it will send you a pull request with your metadata file that was detected automatically, right? So yeah, I think moving in that direction is very, very beneficial.
I also have a quick question. So one of the previous slides, there was this like white slide with a list of different features, and there was like a color coding. So now if you shared your slide, I could have.
Sure, I can share my screen again, no problem.
Yeah, and then there were these. Okay, that slide. Okay, so what are these things in the brackets? It's like HAS.
So I mean, this is
okay.
this is the
Did I not
legend,
see
right?
that?
SC stands for supervised classification, header analysis. This is what basically well, let me tell you I can tell a little story about this, because we started doing supervised classification, which goes like paragraph by paragraph in the README files. But training classifiers on each of the categories is very costly, because there is no corpus for this, and we had to do it manually. So instead, we started analyzing also the headers, and it turns out that the headers are a very good indicator for the different metadata categories. For example, if someone says installation, it's very likely that what it's beyond that header, it's installation instructions, right? So we started, we did an analysis on over, I think it's 90 repositories of different scientific communities. And then we started seeing how different people were labeling their headers. And we took the most common ones, we clustered them together according to their meaning. and that's the result that we extract. Does that make sense?
Yeah, absolutely. So you essentially, okay, that's very interesting. So you have a model to help you extract these fields. You have kind of like you trained a model to do this.
Yeah, we have 4 supervised classifiers, and the rest are, well, for example, regular expressions. Well, if you have in the citation code, you put bibtec, we can detect that bibtec code, which is easy to do, and then we can detect the citation, for example. Or in the header analysis, as I just said, is based on synsets, and there is a room for improvement, but that very simple initial analysis led very good results, like above like 80% of accuracy for many of the categories. And it's good enough, right, as a start. Of course, we are trying to improve.
And is your code also on GitHub?
Yeah. I provided the link here. This is the code. I mean, you can give it a try. I have a binder. We have like a binder notebook. So if you want to give it a try directly on binder, but if you want, there is also a Docker file, so you can build the Docker file out of the code and just plug it wherever you want to plug it.
Daniel, could you please put that link in the chat?
Absolutely.
Thank you. Sorry.
I need to stop sharing though. So
yes. Okay, I'm sorry, Anna. I didn't mean to cut you off. Did you have another question?
No. I was just saying, like, thank you. It was very interesting.
Kristen?
Yeah, Daniel, I work on the information management software registry, and we had implemented that in Ontosoft. And I was wondering what the future of that project is.
Of which project? Sorry, Ontosoft.
Sorry, Ontosoft. Yeah, I noticed it was listed here next to your name in the agenda today, so I thought maybe you were going to talk about it. Yeah.
No, I wasn't talking about Ontosoft today. Well, Ontosoft right now has evolved into different projects, but we, as far as I know, we are Yolanda's group is still maintaining it, and it's, well, right now it's not in active development, so it reached like a status that it was stable, and I think there is no more development as of right now.
Okay, thank you.
No problem.
All right, so I'm going to stop recording, and I want to thank Daniel very much for